Oh, we got it. Technical issues. Good evening, everybody. This is VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3CSJ in Narre Warren South. We're broadcasting on prime frequency of 3541 kHz in the 80 metre amateur radio band. We're also simulcasting on 160 metres on 1865 kHz amplitude modulation. We're also streaming live to the YouTube website, which you can find either direct via the YouTube search engine. Just type in VK3CSJ and look for the live transmission, and or you can locate it under the Astronomical Society Victoria website under the Radio Astronomy tab via www.asv.org.au, and all will be revealed. That's my producers in the background there chatting to me. Okay, and I've been told the YouTube audio is, I can actually see that. It's too much level. Let me just reduce that level down on YouTube. It's always something, always something. 1, 2, 4, 1, 2, 3, 4. Okay, oops, no, that's still peaking. I need to get some limiters in here working for me on my behalf. 1, 2, 3, 4, that should be a tad better. Anyway, cheers to everybody. There's my Arecibo coffee cup you can see on the screen there. I just wish I had had a chance to visit that observatory before it collapsed. All right. We have, I know, a few viewers up at the Allen. Thank you. We also have several viewers up at the Leon Mao Dark Sky site watching tonight. A very pleasant good evening to you guys, and trust you're settling in for an entertaining 2 hours. No, it's actually, I suspect it'll be a short session tonight, but I say that every week and it always goes into a lot longer. Anyway, let me get into the usual stuff that I go into, and to kick this off, I haven't mentioned, we're also got an email address, vk3ekh@gmail.com. So if there's any signal reports or anything such like, please send email to vk3ekh@gmail.com for the next hour, and I'll be constantly looking at the inbox. We also have a Discord chat window operating. Discord can be approached from the ASV website under the Radio Astronomy tab on the homepage there, and just look for the link to the broadcast, and there's a little icon with a radio telescope on it, and that's it, the link to the Discord, and you can just come in as you are or whatever. But there's already a few folks there I can see. Cassiopeia, Nebs, g'day Nebs. Martin, VK7JAH down at Launceston, and Richard, VK3VRS, g'day chaps. I'm sure it'll grow over the next hour. Anyway, all right, I wasn't too sure which way I was going to go with this one tonight. This dialogue is getting a bit old to read. The Astronomical Society of Victoria was founded in 1922, for those that don't know this. Comprises well over 1,600 members throughout Victoria and other states, and overseas membership. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, to disseminate the knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, with the latter being held on a Saturday night. Meetings start at 8 p.m. on the Noggin at the Mulia Hall, National Herbarium in Melbourne near the Melbourne Observatory, which is located adjacent to the Shrine of Remembrance. Parking is available Burwood Avenue, Dallas Brooks Drive and the surrounding streets. Admission is free and visitors are most welcome indeed. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at Melbourne Observatory, receipt of the ASV magazine Crux, containing articles, news, observing notes and the like, and the free provision of the Astronomical Yearbook, which is this book up here. You can see that's the Astronomical Yearbook. That's the latest one. Quite a magnificent publication that the ASV produces on an annual basis. The amount of effort that goes into this is quite stunning. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, weather permitting. The instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor which is managed by the Royal Botanic Gardens, and a recently restored photoheliograph are also housed at the observatory and are accessible as well. The Society also has a number of 200mm reflectors available for short period loans, so members can try before you buy. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, and the larger two only requiring appropriate training, which range from 300mm to 1000mm in aperture. Also located on the site is an 8.5 metre fully steerable radio telescope, which members can access with involvement with the radio astronomy section. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics, historical studies and research, and astronomy in general. Contact details for various section directors are provided in the yearbook. Further information may be obtained by visiting the ASV website, and notifications of events are given in the Crux Extra Bulletins every other week, which is sent out via email to members. Please note that the ASV will conform to all government health directives. ASV events may be required to be cancelled, moved or postponed. Further information can be found by writing to the Secretary of the Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. That's the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. The Astronomical Society of Victoria would just make sure I put the book down somewhere safely. Something doesn't turn off around here. The Astronomical Society of Victoria would like to say, in the spirit of reconciliation, we acknowledge the traditional custodians of the country throughout Australia and other connections to the land, sea and community. We pay our respect to their elders past, present and extend the respect to all Aboriginals and Torres Strait Islander peoples today. So, now, let's see. All right, we have a few other folks that have just called in on the email address. So I just say a very pleasant good evening to Don, VK3HDX, Andrew, VK3KIS, I think it might be, and Ian, VK3VIN up there in Bendigo. And also we have Graham, VK3GRK, who's joined in. Graham is a member of the Bendigo District Astronomical Society, which is now a subsection or a section of the ASV. So good evening to Graham. And Brett, VK2CBD, has joined in there on the chat window too. G'day, Brett. Right. Okay, let's get into this. You're tuned to ASV Radio, VK3EKH. Now we have a picture to bring up, and here it is. Okay, so what we have here. And this is full of Russian names, so I'm going to struggle with the pronunciation. You'll have to bear with me on this one. But this is Valerie Polygov, record-breaking cosmonaut, dies at age 80. The superlative spacefarer spent some 437 days straight in Earth orbit, helping test the limits of the human body and mind and spirit. 21st of September. And the picture here is Valerie Polykov poses for his crew portrait for Soyuz TM-18, which launched from Baikonur Cosmodrome on Jan 8, 1994, and docked with the Mir space station on Jan 10. Polykov spent the next 437 days aboard Mir, making it the longest single space flight to date. When humans finally tread the Oceanic Plains of Mars for the first time, one might glance up at the heavy dust-laden skies and tender a wordless note of thanks to cosmonaut Valerie Polykov, who helped pave the way. Polykov died Monday, September 19, 2022, at the age of 80. Valerie Polykov is known for carrying out the longest single space flight in history, spending some 437 days straight on the Mir space station between 1994 and 1995, and over the course of two-mission career, Polykov logged nearly enough time off Earth's surface to complete a theoretical round trip to the Red Planet and back. A theoretical, that is to say. The vulnerable lessons we learned from Polykov's extended space flights have not only helped us protect the dozens of astronauts that have since orbited Earth, they also might set the stage for what someday could be humanity's greatest achievement, venturing to a planet beyond our own. So let's take a closer look at Valerie. Valerie Polykov's name is now in the record books, but this extroverted, physically imposing bear of a man entered the world with a different name. Valery Ivanovich Korshvanov, how's that? Was born April 27, 1942, in the industrial city of Tula, located roughly 180 kilometers south of Moscow. At the age 15, however, he changed his middle patronymic family name, to a Vladimirich Polykov in honor of his adoptive stepfather. Polykov initially studied medicine in Moscow, specializing in astronautical medicine at the capital's Institute of Medical and Biological Problems. He went on to become a Soviet cosmonaut in 1972, through his wait for an actual spaceflight proved long and arduous. Finally, on August 29, 1988, Polykov launched to the Mir space station aboard Soyuz TM-6, accompanied by fellow cosmonaut Vladimir Glukhev and Afghanistan's first spaceman Abdul Ahad Ahmad. Oh boy. His crewmates returned to Earth's surface a week later, but Polykov remained on Mir to oversee the health of Vladimir Titov and Masov Manarov, two cosmonauts who were nearing the conclusion of the world's first year-long spaceflight. Titov and Manarov returned to Earth in December 1988, but Polykov remained on board Mir to welcome two new crewmates. Polykov ultimately didn't return to Earth until April 27, 1989, with a duration of 241 days. The cosmonauts' first mission ranked as the third longest spaceflight at the time. But Polykov's next mission would be longer still. By the late 1980s, Russia had decisively pushed the envelope for long-term spaceflights, yet the effects of microgravity upon the human body remained imperfectly understood. Cosmonaut Yuri Romanikov, who flew for 326 days in 1987, found himself working less, sleeping more, and exercising vigorously as his mission approached its end. longer flight missions, planners realised demanded close medical supervision of the crew, and better yet, they demanded a medical expert on the crew. Polykov was one such expert. In 1993, he volunteered to be stationed on Mir for 18 months. But his planned November launch aboard Soyuz TM-18 was delayed until January 8, 1994. And with plans for NASA's space shuttle to visit Mir in mid-1995, Polykov's mission was further cut back, first to 16 months, then to 14 months. Joining Polykov on Mir for the first 6 months of his off-world marathon were Viktor Afanasev and Yuri Agizov between July 1994 and March 1995. They were replaced by 3 rotating crews of cosmonauts and astronauts from Russia, Kazakhstan, Germany and the United States. While aboard Mir, Polykov supported 25 life science investigations, which emphasised diet, the human muscular system, the lungs and immune system, the blood and central nervous system, and the balance regulating the role of the inner ear. Early in 1995, quietly and without fanfare, Polykov's mission surpassed Titov and Manarov's record of a year in orbit, but by now the end of Polykov's spaceflight glinted like a mirage on the horizon. In February 1995, Space Shuttle Discovery drew to within 9 metres of Mir, photographing a beaming Polykov at one of the station's windows. And I've got that picture. I shall change that to this one here. There it is. There he is beaming through the window. In February 1995, Space Shuttle Discovery drew, I just read all that, 9 metres of Mir, and of course, a few weeks later, Norm Targard joined Polykov on Mir, becoming the first US occupant of the Russian space station. As Polykov's record-breaking spacecraft neared its conclusion, the good doctor's excitement at the prospect of seeing his family again was readily apparent. He's a big guy, an extroverted guy, but can be sort of like a bull in a china shop, remembered Targard in a 1998 oral history of the Space Shuttle Mir project. He was apparently being real rambunctious, just listening to him on the radio as they were undocking and flying around before entering. At one point, Viktorenko had to tell Polykov to calm down. Finally, on March 22, 1995, Polykov aborted the Soyuz TM-20 spacecraft with Alexander Viktorenko and Yelena Kondakova, good grief, beginning his long-awaited trip back to Earth. Touching down on terra firma after 437 days, 17 hours and 58 minutes in space, having circled the globe 6,927 times, Polykov's flight still remains our most relevant case study on how our frail bodies might endure a voyage to Mars. Even after 63 weightless weeks, Polykov seemed none the worse for wear, insisting on walking from the Soyuz capsule to a nearby chair under his own power. And this mental state too seemed good, despite various little dips in his mood during the first and last months in the epic mission. Finally, Polykov's legacy. Humanity's endurance in space had advanced with impressive pace since Yuri Gagarin's 2-hour flight in April 1961. Within 2 decades, cosmonauts were routinely spending 6 months in orbit, and by the end of the 1980s, men survived off-planet for up to a full year. Yet only 8 missions, including Polykov's, have spent longer than 300 days in space, and an achievement that, well, needed to be more than a double if we are to ever explore Mars in person. Our physical well-being is one long poll. When Scott Kelly returned to Earth in March 2016 after 430 days on the International Space Station, he found himself stumbling as his legs leaned as his legs learned to walk again. All of my joints and all of my muscles, he wrote in a memoir, Endurance, are protesting the crushing pressure of gravity. More recently, in February 2020, Christina Koch completed 328 days in space, the longest single mission by a woman. And just last March, Mark Van Der Hee and Pryatar Dabrov wrapped up an International Space Station stay that lasted just 10 days shy of a full year. Right now, Mars is the only planet in our solar system entirely inhabited by robots. But when the first humans arrive, possibly within our lifetimes, we can hope that they will remember the accomplishments of intrepid explorers like Valerie Polygov, a man who pushed the boundaries to demonstrate that flesh and bones can survive the great unknown, and for when the first human does stand triumphantly on Mars's surface, he or she will stand on the shoulders of a true Titan. Righto, said the man. There it is. So, and he passed away on, when was that date again? On 19th of September at age 80. So there you go. You're tuned to ASV Radio VK3EKH, coming to you from the studios of VK3CSJ in Narre Warren South. Time is 24 past the hour. Okay, next article. And this has got a couple of pictures in it too. Blob of hot gas whirls around Milky Way black hole at the 30% speed of light. Astronomers further constrain the shape of the magnetic field of the Milky Way's supermassive black hole Sagittarius A. And there's a picture here. So I shall bring that up to carry on. The location and orbit of the hot spot in relation to Sagittarius A is shown in this artist's concept, although the image in the middle is of the accretion zone, I think, of that black hole in the middle of the galaxy. Tucked away in the heart of the Milky Way galaxy is a slumbering giant known as Sagittarius A, pronounced A star. While some supermassive black holes can be extremely active, devouring large quantities of gas and dust that glow brilliantly in X-rays, Sagittarius A, or Sag A for short, is rather lethargic in comparison. But occasionally, Sagittarius A will put on a fleeting show. While the Event Horizon Telescope, EHT, had its eyes trained on Sagittarius A in April 2017, collecting data for the first image of our galaxy's supermassive black hole, and a armada of telescopes also targeted the giant black hole, and on April 11, NASA's Chandra X-ray Observatory spotted a powerful burst of X-rays. And here we have this image, which is a GIF image. There it goes, it's moving, good. So, this is the Chandra recorded the flare event on April 11, 2017. By coincidence, the Akakama Large Millimeter Submillimeter Array, ELMA, was taking observations of Sagittarius A for EHT when that X-ray flare occurred. Filling an important data gap, the research was published today, 22nd of September, in Astronomy and Astrophysics. What is really new and interesting is that such flares were so far only clearly present in X-ray and infrared observations of Sagittarius A, said lead author Mayak Welgus of the Max Planck Institute of Radio Astronomy in Bonn, Germany. Here, we see for the first time a very strong indication that that orbiting hot spots are also presentable, or do present in radio observations. Black holes are objects where gravity is so strong that nothing, not even light, can escape. The event horizon, that's the word I was thinking of. The event horizon, or surface, of the black hole marks the boundary of no return. Astronomers can only theorize as to what goes on beyond this point. But the region outside the event horizon isn't free of mysteries either. Scientists don't fully grasp what causes flares, such as the one Chandra detected. One theory points to the interactions between material and the black hole's accretion disk, and the magnetic field surrounding the black hole. In the case of Sagittarius A, the researchers think the magnetic field acts as a barrier, preventing the black hole from devouring as much material as it otherwise would. This magnetic blockage causes gas and dust to clump up in certain areas around the black hole. Eventually, this built-up tension causes one of the magnetic field lines to temporarily break, allowing the black hole to gorge itself. The breakage also releases energy into the surrounding material, forming a hot bubble of plasma. Initially, these hot spots might primarily emit X-rays, Wilgus wrote or told Astronomy, but maybe it needs a bit of time to cool down to show up at low frequencies corresponding to millimeter radio wavelengths. It was these latter wavelengths that ALMA was able to detect. On average, a hotspot typically lasts for a single orbit before being sheared apart by the black hole. In this case, the clump of gas was zipping around the Milky Way black hole at some 30% the speed of light. At those mind-bending speeds, it was able to complete a lap in about 70 minutes, and it was torn apart some 35 minutes later. While the new observations support a magnetic origin of these energetic flares, they also offer a glimpse at the true shape of Sagittarius A's magnetic field. Like with M87, more data from EHT telescopes may provide a more complete view of our galaxy's central black hole. Hopefully one day, Wilgus said in a ESO press release, we will be comfortable in saying that we know what is going on in Sagittarius A. Well, we can only hope in that respect. Alrighty then, you're tuned to ASV Radio, VK3EKH, coming to you from the studios of Narre Warren South. Cheers. I need a bigger cup. The coffee just doesn't last long. Very pleasant good evening to everybody up at the Leon Mao Dark Sky site. Tomorrow is the Galactic Star Party, and everybody is warming up for quite a good turnout, and hopefully the weather will keep everybody keep at bay, and clear skies for everybody that's up there. So enjoy yourself, guys up there. Enjoy yourself, that's for sure. Okay, James Webb Space Telescope's latest. JWST snaps the clearest image of Neptune's rings since Voyager 2. NASA's latest and greatest space telescope recently set its sights on the solar system's most distant planet, and the results are stunning. September 21. And of course we have an image, so let me just bring that up. Okay, so what we see here, just before I carry on for a sec, Richard, is the signal on the repeater still there? Just let me.
Yep, it's all good.
Okay, I've got a no signal on the screen up here for some reason. Oh well, it's okay. Thank you. Okay, so what we're seeing on the screen here is NASA's James Webb Space Telescope used its near-infrared camera, NICAM, to capture this incredible shot of Neptune's turbulent atmosphere and ethereal ring system, Neptune's moon, Triton, at the left, outshines the planet because Neptune's atmosphere is rich in methane gas, which absorbs light at the wavelengths JWST is sensitive to. And that's what we're seeing here. So Neptune's delicate rings and even fainter dust bands come into clear focus in this recent image captured by NASA's James Webb Telescope, located some 30 times farther from the Sun and Earth. Neptune, the solar system's most distant planet, isn't an easy world to photograph. However, thanks to JWST's space-based vantage point, impeccable stability and impressively large 21-foot diameter primary mirror, the telescope was able to capture Neptune's features with a clarity that hasn't been achieved in more than 30 years. Perhaps the most striking aspect of the new image is Neptune's ethereal ring system. Some of these rings are so faint that they haven't been detected since NASA's Voyager 2 probe became the first spacecraft to closely observe Neptune during its flyby in 1989. It has been 3 decades since we last saw those faint dusty bands, and this is the first time we've seen them in infrared, said Heidi Hamel, a Neptune expert and JWST scientist. The solar system's ice giants, Neptune and Uranus, are richer in heavy molecules than the gas giants Jupiter and Saturn, which are almost entirely composed of hydrogen and helium. Specifically, the ice giants have a relative surplus of gaseous methane, which gives them their characteristic blue hue in visible images like those captured by the Hubble Space Telescope. According to recent research, Neptune's turbulent atmosphere is more efficient at dispelling haze from its cloud tops, giving Neptune a deeper blue appearance than Uranus. Because methane gas strongly absorbs the wavelengths of light, JWST's near-infrared camera is sensitive to 0.6 to 5 microns. Neptune appears surprisingly dim in the image above, or in the image you're seeing on the screen. That's how Neptune's nitrogen-covered moon Triton at the top left manages to outshine the giant planet. High-altitude methane ice, meanwhile, better reflects sunlight, resulting in the bright streaks and spots visible on Neptune's disk in this particular shot. Thanks to JWST, even our solar system's most distant world is making its way back into the limelight, and with additional observations of both Neptune and Triton planned over the next year, there will surely be more captivating shots to come. Pretty good. Okay, you're tuned to ASV Radio, VK3EKH. Time is almost 24 minutes to the hour. Now, I held over this particular article a couple of Fridays, so let's have a look at Earth for a moment. And there's a couple of images here that I'll throw up as well. Why does Earth have continents, you might ask? Our planet, there I am. Our planet is made up of continents, and that makes us the oddball of the solar system. No other planet has continents like we do, and it is unclear why, apparently. Okay, if you were to arrive in our solar system never having seen it before, you'd be impressed with variety. Giant gas planets with rings, moons spanning the minuscule to the enormous, icy comets that hurtle from the edges, rocky planets, all with varying amounts of atmospheres. It almost seems like no two planets or moons formed the same way. But one really sticks out as an oddball. It's Earth, Mother Earth. Our planet has liquid water. Weird, you might think. It has life, even weirder. It has plate tectonics, churning away continued, which is in brackets here, continued weirdness. It even has gigantic masses of rocks unlike anything else in the solar system, totally weird. Those masses are the continents, made of rocks like granite, sandstone, gneiss, slate, andesite, rhyolite, and more. The rest of the planets are almost entirely basalt or something close, but Earth, no. Earth hides most of its basalt surface under deep oceans, instead letting its freak flag fly, with continual rocks showing off to any passerby. All of these unique features are connected. Plate tectonics may exist on Earth because we have liquid water at the surface. Life might be a product of the abundant water and volcanism. The composition of Earth's continents might be a product of life's interactions with rock. It is all deep time evolution of minerals, rocks, and organisms that make Earth what it is. So, what are continents anyway? There is still a lot unknown about the formation of our continents. We're pretty sure that no other planet has the silica-rich continental masses that Earth possesses. Mars might have a little bit of geologists called evoked rocks, in other words, more silica than basalt. Venus could have a little bit as well. The Moon has andesite highlands, which are a bit like continents, except they are formed from lighter minerals floating in a primordial magma ocean and those highlands are mostly all the same stuff. No planet has the complex melange of volcanic rocks, sediment and metamorphic rocks, and cooled magma that are Earth's continents. The current theory, based on the ages of tiny zircon crystals found in Australia, is that our continents may have started forming over 4 billion years ago. However, whether they are formed quickly too close to their current size or have been slowly growing over time is an open question. So what makes continents so special? Well, they are less dense and much quicker than the other flavour of plate on Earth, oceanic plates. Our ocean basins exist mainly because the crust underneath them are denser and thinner basalt plates, meaning they sit lower on the Earth's ductile mantle. The continents, on the other hand, sit high because of their lower density and thicker profile, much like a volleyball sits higher in a pool than a tennis ball, a concept we call isotachy. This difference does more than just create the different shapes of Earth's surface. Continents are so buoyant that they can't get shoved back into Earth's mantle like the denser continental crust. Thus is born features like mountain belts formed from continental collision and subduction zones and their volcanoes, where oceanic crust dives underneath continental crust. The continents change as well. With plate tectonics comes the Supercontinent Cycle, known as the Wilson Cycle, where continents collide to form massive supercontinents like Pangaea and then split apart over hundreds of millions of years. Today, the only thing we have close to a supercontinent is the amalgam of Europe, Asia and India. The oldest parts of our continents are called cratons, and if those rocks are exposed at the surface, they are called shields. They represent the nucleus of each major continent, usually much smaller than the continent as a whole. These areas haven't seen much in the ways of active tectonic processes like collisions or rifts for hundreds of millions or maybe billions of years. In North America, the craton stretches from northern Canada, and Greenland, where the oldest rocks go back to 3-4 billion years, to the south into Texas. But only parts of it are exposed at the surface. Most continents are more than just their cratons, so we know that the continents didn't form all at once in the early history of the Earth. You can check out a map of the world's cratons. Below is to get a sense of the old cores of continents. There is an image here, but it's probably a little bit vague. This is what they're referring to at the moment as I read this. So in this image, it's a map of the world's geologic provinces. The areas in orange are the oldest craton shields that they're referred to. One of the biggest questions might be, what got the whole continent thing started and what keeps it going? It didn't seem to happen at the other rocky planets of our solar system. This means that there are some factors that are likely intrinsic to Earth, our liquid water and molten solid core, that helped continents to develop as fully as they have. However, as they say, that's not all. Okay, that's actually the end of that. So, yeah, anyway. Well, I hope you got something out of that one. But I was holding on that for a couple of weeks, so I thought I'd better read that out. You're tuned to ASV Radio, VK3EKH. Let's go on quickly to the next one that I've got here. We're coming up to the end of it, actually. Now, sometimes... Ouzo. Sometimes I like to feature a profile of amateur astronomers. Certainly, if there's an article to read, I'll read up on amateur astronomers and what they get up to and their thinking. In this month's Sky and Telescope, oh, that's great. There is an article on Diego Coleno. I think that's how you pronounce his surname. And very pleasant good evening to Diego if he's watching this. It's only it's not very big, the article, but I know Diego, and my thinking is I'll probably end up getting to know him a little bit better in a few months' time, as I've as mentioned last week, I've put a bit of a deposit on a scope dome, a 3-meter scope dome, which is still sitting in Poland and getting made, but I suspect it will land in Melbourne sometime mid maybe next year. So finally I'm going to be getting an observatory set up in the backyard here, and I'll probably get a little bit of help from Diego, maybe Gavin, and Brent, I think it was. Anyway, this is the article. Oh dear. Let me see if I can move it across so I can... Yeah, there it is. In less than a decade, Melbourne-based Diego Coleno has gone from being a budding amateur astronomer to an accomplished astrophotographer and proprietor of a company, astroworks.com.au, that builds high-tech telescopes as well as offering observatory packages and accessories. He says he is driven by the goal of being an Australian manufacturer who can bring a difference to the market. So, the question is, what got you into astronomy? He says, more than 15 years ago, I tried to do a bit of research about what can be seen with a telescope, and I was disappointed with what I found. Then in 2016, I was in a supermarket and saw this Brescia telescope on a cheap equatorial mount for about $100. I thought, what could go wrong? Later that night, I saw Saturn. I couldn't believe it. And so I tried to take a photo with my mobile phone, and that's how it all started. Next question. What was your first telescope setup? My very first telescope was that Brescia 70mm refractor, and my first astrophotography rig was a 20cm f5 Newtonian on an equatorial mount and a Canon EO6 40D camera. That 20cm made me fall in love with Newtonians and astrophotography. What sort of gear do you use now? At the moment, I have a backyard observatory that houses an Optron CEM60 mount and one of the very first AstroWorks telescopes we have made, a 25cm f4 Newtonian with a closed carbon tube. My camera is a QHY268 and I use an Astrodon filters and an off-axis guider. Soon after starting to use Newtonians, I found that off-the-shelf telescopes needed some modifications in order to work better. Things such as carbon fiber tubes, better focuses, and improvements in the mirror cell. It all helps when imaging. That is why I started building telescopes from scratch. What has been your favourite moment in stargazing? My favourite moment has to be my experience with astrophotographer Alex Cherney at Cooper Pedy in South Australia, documenting the re-entry of Japan's Aerospace Exploration Agency's JAXA Hayabusa 2 asteroid mission sample return capsule. I was invited by Alex to help with the logistics and video filming of the event. I happened to be, in brackets, stressed, owner of the hand that tracked the capsule across the sky. It was an event that I will never forget. Thanks Alex, JAXA and the Hayabusa 2 team. What sort of astro activities are you involved in? At the moment, I am on the Council of the Astronomical Society of Victoria. I also have the pleasure of working by day building telescopes and astronomy accessories. I have a lot of fun travelling to install observatories for our clients. What's on your astronomy to-do list? He is asked. My priority at the moment is to grow as a manufacturer. It has been challenging to create an Australian telescope factory. Big words, I know, but the dream is to design and build astrographs for everyone, from amateurs to satellite communications companies. That is the goal. So there it is, and there's a photograph, one of his photographs that he took. I've just got it here. There it is, and that's this is when Diego isn't building telescope, he's taking images through them, such as the one here of Thor's helmet, and a beautiful image. I am hoping to be able to do the same thing in due course. You're tuned to ASV Radio, VK3EKH, and that was, out of the latest Sky and Telescope. And, of course, also in the latest Sky and Telescope, and I think I'll end on this one. I'll just skip to the end. Is a nice little article, I figured. And, come on, it was just here. There it is. Okay. This, I think dads with sons can probably appreciate this little article. This is written by Martin Hajovsky. Why do people have strange names? Here, Dad, take a look. And this is in regards to Saturn. I really didn't think stargazing with my son one night would bring us almost to tears. The sight and sound stopped me in my tracks. There was my 20-year-old son lining up my Celestron CPC 925 to find Saturn through the eyepiece. When he said those 5 simple words above, "Here, Dad, take a look," it brought back a surprising flood of memories, both of my father and my own journey as an amateur astronomer, emphasis on amateur. Growing up in the Apollo lunar missions era, I learned to love the night sky at a very young age. One night I stood in front yard and stared at the moon hard during the Apollo 16 mission. My dad came out to collect me for dinner, and I told him I thought I could almost see the astronauts up there, walking around. He gently pointed out that not only could I not see them, but no telescope was powerful enough to find them. They were just too small and too far away. I remember being struck by that sense of scale and distance, and I knew then, sharing that moment with my dad, that my adult life would definitely consist of exploring the night sky. Of course, it didn't. Not in a professional sense, anyway. By the time I was 15, I'd saved enough money to buy my first telescope, an Edmund Scientific Astroscan 108mm reflector that I still own. A friend of mine thought a telescope could look like many things, but not a little red ball with the cylinder sticking out of the side. He called it a bogus and gave it its name, a bogyscope, which made both my dad and me laugh. But did I ever love touring the sky with a bogyscope? The ultimate dream, though, was a Celestron C8. Its bright orange tube filled my dreams the way cars filled those of my friends. To be fair, I dreamed of those too. When it comes to dreams, why stop at one? The C8's price tag was well beyond my old job income. My parents, in brackets, $1,000 for a telescope, question mark, in close brackets, had doubts about how well I'd take care of it, which I admit would probably be well founded. My father, however, loved looking through the bogyscope with me. One time I lined up the eyepiece on Saturn, turned and said those same words my own son would say to me 40 years later. I can still remember my dad crying out, "Whoopee!" when we saw Saturn's rings. There they were, he said excitedly. Or there they are, he said excitedly. And they were right there. I never thought you'd be able to see them through a little thing. My recent observing session with my son brought me full circle to that long ago night. I've never said get that C8 instead settling on a slightly grandier CPC 925, a slightly grandier telescope. My parents are no longer with us, but I like to think that they would have been happy indeed to see their grandson turn to their son and call them over with the same irresistible invitations. Here, Dad, take a look at this. So there you go. We all have our own little personal connections with astronomy, and mine's been a love affair for a long time with a set of 12 by 50 binoculars that were given to me, I think, as a birthday present, maybe Christmas present, and that's all I've ever seen of the sky is through a pair of 12 by 50 binoculars. Not to mention seeing the night sky up at the Leon Mao Dark Sky site. But of course, recently, in recent times, I managed to come by a Celestron 800, courtesy of the ASV, and very, very soon we'll be getting that into an observatory and using it in a real sense. My 160 meter transmitter is having a hernia for some reason. Anyway, let's go to spaceweather.com. Let's see what's happening up in space. This is VK3 ASV. I wish. VK3EKH. The solar wind is currently at a speed of 408 kilometers a second at a density of 5.78 protons per cubic centimeter. Oh yes, and I've got a picture of the sun here too to bring up. There it is. Doesn't seem to be as high res as it should be. Don't know why that is, but anyway. The current sunspot number is 99, and this is the current disk of the sun. There is 5 sunspots on the disk of the sun as we speak, with one just on the outer rim there I can see. And there are chance of storms today. NOAA forecasters say that a minor G1 class geomagnetic storm is possible on the 23rd, when a high-speed stream of solar wind is expected to hit Earth's magnetic field. The gaseous material is flowing from an equatorial hole in the sun's atmosphere. The high-altitude auroras are possible when the windy stream arrives. There might even be a chance of seeing Aurora Australis down here. So keep your eyes out tomorrow night, guys. There might be a little bit of aurora on the horizon. The radio sun is currently at a solar flux. It's pretty high. The solar flux is currently 137 solar flux units, measured at a wavelength of 10.7 centimeters. So that's a pretty busy sun. And to go down to my favorite, as of September 23, 2022, there were 2,293 potentially hazardous asteroids. 2,293 potentially hazardous asteroids. So that's it in a nutshell. In fact, I'll just take a quick look of the aurora over Antarctica. Oh yeah, okay. There's a reasonable glow in the sky as we speak, beaming its way towards Australia. I didn't save the image, so I won't bother, but you can take my word for it that there's a decent auroral ring over Antarctica with a emphasis towards the mainland. So things are looking up. All right, something's playing up with my 160 meter transmitter, so I better give that a rest. So this is VK3EKH. I want to thank Phil, Don, Andrew and Ian for their emails that I've sent in tonight. And to the folks on the chat window up there as well. We've got Graham and Bill, VK3KHT, Brett, VK2CBD, and Richard, VRS, Martin, VK7JAH, and VK3JL, and I think that's Dave. He's up there at LMDSSS. Steve, VK3SPX, and all right, there it is. So thanks very much for settling in tonight, and for all those folks up at the LMDSS, have a good time tomorrow. Hope the weather is nice. It'll be a bit chilly, I think, but just hopefully it won't rain. I don't think it'll rain. It should be fine. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, concluding transmissions on 160 meters. So any stations that are on 160, there will be a callback on 80 meters, 3541. So we shall conclude our medium wave surface and give my linear a rest, because I think it's the linear that's playing up at the moment behind my head up here. It's just this one just in here, I think, is having a bit of a hurt. Oh, actually, not that one. It's the one up there. I think it's doing something funny. Anyway, don't worry about that. So don't have to worry about that. So this is VK3EKH with VK3CSJ on the microphone, concluding transmissions. Any information about the ASV can be found at www.asv.org.au. This is VK3EKH concluding transmissions on 160 meters AM on 1865. Standby stations on 80 meters. All right, give that a rest. I can hear all the fans going now. All right, so this is VK3EKH with logbook and pen in hand, and we're going to take a quick listen on 3541 for any stations wishing to check in. Alright, there was a very weak station there. VK3GL, VK3VIN, VK3BDA, VK3HDX. There was a double there, and VK7JAH. Who did I miss out? Oh, wrong one. Okay, now there is a very weak signal there. Can anybody hear who's trying to call in? Yeah, okay, PDG. That call sign sounds familiar. Very weak here, but we'll get to you in a short moment. Graham, have a say. VK3 Golf Lima, VK3 EKH. Yeah, Roger Graham, you still watching the YouTube feed?
No, not at the moment. I will go and I'm on a different window at the moment. It's actually running, but I'm on a different window, over.
Oh, okay. No, I've just brought up a quick picture of the internal of one of these scope domes. It's Diego is standing inside his dome with his super telescope there. But it's not an external shot, but rather a looking in from outside into the internal side of the dome. So that's and that looks like a 3-meter dome. Actually, might be a bigger dome, but that might be the 4-meter one. But anyway, you can see it on the visions right now. So I'll leave it there for a couple of minutes before going back to me. Thanks, Graham. Yeah, you're a good signal tonight. Strangely enough, it's compared to previous weeks. Well, you've explained it. You've raised your tower and increased the height of your antennas, so that makes all the difference. Thanks, Graham. Across to you there, Ian. VK3 VIN, VK3 EKH.
altering the feeding system and lengthening it to random lengths. So there we have it. Yeah, I can hear all your fans whistling away there, Clint, on your amplifier, etc. So 20 to 30 dB over 9 for you, and there is an email there for you that I sent toward the end of the broadcast. And I was very interested in the article that talks about the development of the continent on Earth. I didn't process the whole lot, but enjoyed it. And particularly for those of us who have never seen things related to our Earth, it's good to get that sort of information. And what about interviewing Diego on the news? Set aside a little 15-20 minute segment and try to entice him to come aboard and have a chat. That would be really good to hear from another amateur astronomer. And I must check with my son Lee to see whether he's still getting Australian Sky and the telescope, because he used to be a real fan of that magazine. Okay, great broadcast. Thank you for it. And I'll sit back and listen to the rest of the check-in. VK3EKH.
Yeah, no worries. In VK3VIN, VK3EKH returning, and yeah, your signal was varying a little bit. It faded into the noise there a couple of times. I actually struggled to hear what you were saying, but I got the gist of it. And that you're interested in the article on the continents, which was interesting. I'm glad that at least one person out there was interested in the article. And I can see your email here. I can certainly forward a link to that article if you're interested. It's all courtesy of astronomy.com website under the news tab. So yeah, I can forward that link onto you if you're interested in having a read of that, or having a read of it at least. And what else did you say there? And the noise in the background, that might be because I've got the gain up a little bit too high on the mic over there on the mixer. I'll have to take a look at that. The whole audio system here needs to be seriously looked at. Anyway, thanks Ian. Thanks very much for calling in. VK3VIN and Kangaroo Flat. Graham, VK3 Bendigo, District Astronomical Society, VK3 BDA, VK3 EKH. Have a say, Graham.
Yeah, thanks, Clint. VK3 EKH, VK3 BDA, the call sign of the Bendigo section of the ASV. And thanks very much for the news this evening, Clint. It was always interesting as usual. And good evening, everybody, and good evening, shortwave listeners. Yeah, I think some of our Bendigo section members will be travelling to the site this weekend for activities there at the ASV Dark Sky site. Yeah, an interesting time in Ballarat last week. What are we? Yeah, last week. Went to the observatory and helped out with some school evenings on the Monday, Tuesday and Wednesday. We had 50 on the Monday evening, 100 and 12 adults on the Tuesday evening, and we catered for them as well with food on Tuesday evening, so that was a big night. And we had a small group on the Wednesday evening. And it wasn't all perfect viewing on the 3 nights, but we had some pretty good viewing on one of the nights, and we were able to have some pretty good views of Saturn, which was great because they, of course, were all very impressed with looking at Saturn. And the actual school that was with us on the Monday and Wednesday evening was Loretto College. And of course, they were the girls that had the accident, the bus accident just the other day, and they were off to NASA Space Camp in the US, and unfortunately they took place of that. So, yeah, so that was pretty sad to hear about that, because a lot of those girls would have been with us on the Monday and the Wednesday evening. So, yeah, that wasn't very good news, but hopefully they're okay. Yeah, so, yeah, very good audio. Clint, I was just listening on AU Media this evening. I was doing a bit of a media release for something else, and I was listening while I was doing that, and a really good audio. I'm listening on a 7300 now, so new 7300, which I've had for a few weeks. Enjoying using that, and it makes your audio sound really good. In actual fact, I widened the audio a little bit out to 3.6K, and experienced a little bit better audio quality too there, because you're transmitting very good audio and a very nice signal. It was 20 to 30 over 9 in my radio shack, Clint. With that, have a great weekend. Thanks once again, and I'll put it back to you there, Clint. VK3EKH, VK3 BDA, Bendigo.
Yeah, no worries. Graham, VK3 BDA, up there in Bendigo. You'd be supplying a pretty strong signal to the guys up there at LMDSS, if they're still listening. VK3 EKH returning. Yeah, very sad about that bus accident. Things like that happen overseas. You just can't imagine such a horrible accident occurring here in Australia, and it's fortunate that I don't think anybody was seriously injured. But it is sad that all the plans and everything that those kids were hoping to be involved with has kind of fallen through, at least for the short term. So yeah, it's not wasn't good to see that story on the news. Thanks, Graham, for calling in, and yeah, that's kind of, isn't it funny how like the 6 degrees of separation thing? It's how that brings that to home. It's really amazing. Anyway, across to it's now it's Don. That's it. VK3HDX. This is VK3EKH. G'day, Don. Looks like he's had to, when you got to go, you got to go. You're there, Don, VK3HDX, VK3EKH.
VK3EKH, good evening, Clint. A great broadcast tonight. Really enjoyed it. Loved the pictures of Newton. Was excellent as usual. Really look forward to it each week. Thank you, Clint. VKCPSJ, VK3HDX.
No worries, Don. VK3HDX, VK3EKH. Yep, sounds like I caught you having a nap in the chair there. Oh dear, that's all right. I've got my webcam USB camera on the radio at the moment, so viewers can see the signal strength coming through from the various stations. I need to mix the audio out of the receiver so that a certain amount of level can be easily fed over the TV system and the internet. So I must try and do that. Thanks, Don. Across to Bill, VK3KHT, VK3EKH.
signals, and I was wondering why I didn't meet too. Thank you. Always, I appreciate the program, and greetings to everyone else out there. I'll keep it short. Time to petrol, and VK3, KHT,
Yeah, no problems, Bill. VK3KHT, one of our ATV viewers. VK3CSJ, EKH returning. Yeah, just above the noise floor, Bill. Just above my noise floor. So I can hear what you say, but it's competing with the noise. So thanks for calling in, because I know you usually view. So, but definitely thanks for coming in, and we can hear you. So that's the main thing. Thanks, Bill. Martin down in Tasmania, VK7JAH, VK3EKH. Yeah, no worries, Martin. VK7JAH, Launceston, VK3 EKH returning. Yeah, no worries, Martin. Yeah, signal's a bit better from Tasmania tonight. Usually in previous callbacks, you've been just in that noise floor area, and it has been a bit of a trick. But the 80 metre propagation tonight seems to be just that little bit better. So that's good to know that I was being heard far and wide. Anyway, no worries, Martin. Thanks for calling in, and thanks for the report as well. And yes, I've got the USB camera on the front of the Pro 3 at the moment. So as soon as the station calls in, I'll switch back to the front of the radio. So there's a chance that you can see your own signal strength coming through here. Anyway, thanks, Martin. Now we have another station that's called in very, very weak. We'll give you a go. I've had a quick look at QRZ.com, and it looks like it's Mark is the name. So let's see if we've got it right. VK3 Papa Delta Golf. The call signs does sound familiar. VK3 PDG, VK3 EKH. Have a go.
That should be better. VK3 EKH, VK3 PDG. I feel like a bit of a goose. Graham called me earlier and reminded me that the net was on, and I quickly went outside. My antennas are still outside the cable because I haven't got the mast up, and I'm just using dipoles. And I put the plug in the first 80 metre dipole, I discovered that's not working. I went to the long wire here to tune up on 200 milliwatts, and I also forgot to put the power back up. So I called you on 200 milliwatts. So thank you to all the stations that heard me. Anyway, Mark, as you said, just north of Bendigo at White Dorset, not far from Graham, VK3, normally GRK, of course, north of Bendigo, Astronomical group. And thank you for the report as always. Particularly also enjoyed the report on the continents on Earth and their uniqueness as opposed to other planetary systems. And also really enjoyed the talk about Uranus and the disaster which I was over there today. So it's quite fun, and my family gave me a nice little yearbook for astronomy the other day for Father's Day. So that came up there. For those of you listening, read the accident at Ballarat at Bentley Hills Road. It was announced today that the Space Camp in America have sent their condolences and they've sent their thoughts to the school. So currently they're going to refund the funds and they're going to survey Tuesday. and the teachers and parents involved in making full recovery. So there is a little bit of good news from that. Otherwise, and I'll put it back to you for why doors and hopefully my support will be better. VK3 EKH, VK3 PDG. The 9 in 10 to lose that. That's great. Stay here.
Yeah, thanks, Mark. VK3 PTG, VK3 EKH. That is good news. There's always a side of these stories that hopefully some good news will come through, and it sounds like it has. So that's great. Thanks for letting us know about that, Mark. Really good news indeed for those girls, or the students, I should say. So excellent stuff. Yeah, your signal is definitely up now. I could just hear you on that 200 milliwatts. But when you first called in just a moment ago, you're a good solid 20 over 9. So there's been a little bit of QSB on your signal, but between 10 and 20 it's been quite good. So don't forget to wind your power up. Thanks, Mark. Good to hear. It's been quite a while since you've come up on the end of the net there. All right. Now, is there anybody else wishing to check in before we disappear? VK3 EKH listening. I think it might be VK2. VK2. Just repeat your call sign again. Oh. Yeah, got you, Andrew. VK3KIS, no problem. All right, Frank and Andrew. Have a say, Frank. VK3JR, VK3EKH.
VK3JR, VK3EKH. Good evening, Andrew. Good evening, Ian and others. I just tuned in, actually. Missed the first broadcast, but never mind, I had a distraction. The father and I got a real life PHS, and everyone else is all good copies. So, including you, Andrew, although you're a bit down, that's copyable. Look, I don't have anything except to thank you, as you, what I'm sure was a great broadcast, but actually recorded it, so we're hearing it soon. That's really all I have to say. There will be later missions on 60, if you're interested, or if anyone is interested. That's it. Until next week. Thanks again for doing it. VK3EKH, VK3JR.
VK3JR, VK3EKH. Not a problem. I'm already tuned to 1865, so I always have a bit of as soon as I'm finished here, I've got the volume up, and I'm usually got it in the background running, so not a problem. Now, I had a word with Steve today too on the Coffee Break Net, VK3SL, so it was good to have a quick chat with Steve. I might come up on the Coffee Break Net tomorrow morning on 1825 and say good day to Gus and Steve. He'll probably roll up there as well. But yeah, thanks, Frank. Good on you. And not a problem. You can always watch the YouTube repeat if you wish. YouTube does the wonders of recording this stuff. So there it is. All right, thanks, Frank. Now, Andrew, you're very weak. VK3KIS, VK3EKH. VK3KIS, VK3EKH losing his voice. Yeah, thanks, Andrew. A little bit, again, a little bit hard to catch all of what you're asking, but I think I think you were saying something about a telescope, trying to work out what telescope to use, or that you can use with your current setup and situation. I can probably email you information in respect to that, perhaps types of telescopes. I'm not too sure, but can you, if you like, can you just send us another quick email? Not now, but when you want to, just send us a quick email about what it is that you're specifically after, and I'll see if I can get an answer back to you fairly quickly on that one. But I think you were saying something about it, wanting to know what telescope you can use that will make looking through a telescope easier for the setup that you've got. So it was something along those lines, I think. So we'll find out in a short moment, I guess. Yeah, all right. I'll just take one more listen, and if there's no other stations, I'll conclude for tonight. VK3 EKH listening.
VAT, just checking in, please.
The local lads. All right, I'll just write that down here on the call book to make it official. All right, thanks, Tony, and thank you, Richard. You sure, Dennis, you don't want to check in if you're there? No, he's asleep. All right. With his hearing aid, he should be hearing everything. In fact, I'm probably breaking through his hearing aid from this distance away. You've been watching another episode of the Astronomical Society of Victoria's official regular Friday night broadcast. It's the first time I've said it that way, but there it is. And thank you for watching and listening. To everybody up at the Leon Mao Dark Sky site, again, have a safe and lovely time tomorrow. I don't believe I'll be there, but I know that the radio astronomy lab will be manned by Phil and I believe Steve Bentley, VK3YJQ, if he's up there as well. But to go across and keep the guys over there busy. Don't let them sleep at the desk. So... Anyway, cheers everyone, take care. This is VK3EKH for the ASV, concluding on 3541 kilohertz, and everybody that's been up there on email and chat window, thank you very much, Lee, and we'll see you all next week again at this same bat channel. VK3EKH, concluding on 3541. Aha! That would explain everything. Well, yeah, look,